Module 1 Tolerance in Mechanical Design. In this session, we'll be learning about basics of mechanical tolerancing and how it's used in the drawing. Also, we would understand its role in tolerance stack. First, we'll understand as what is tolerance. Tolerance is permissible variation in the dimensions of the part due to manufacturing limitations of machinery or processes. In this drawing, tolerance is plus minus 0.5, which means length can vary from 14.5 to 15.5. In other words, manufacturer is permitted to produce the part with dimension in between these two numbers. In a mechanical drawing, tolerance can be represented by various methods. First method is nominal with plus minus tolerance. In this drawing, 15 is the nominal dimension and plus minus 0.5 is symmetric tolerance. Next one is limit dimensioning. Here, dimension is mentioned in the form of lower and upper limit. 15.5 is upper limit, whereas 14.5 is lower limit. Third way of tolerancing is geometric dimensioning and tolerancing. This method of tolerancing is called gd&t way of tolerancing. Instead of controlling the center position directly by conventional tolerancing method, we have used position tolerance for the whole center with respect to datum A, B and C. Next topic in this module is tolerance methodologies. We'll be focusing on four primary methodologies of tolerancing, which are trial and error tolerancing, based on customer requirement, based on manufacturing process capability, effective tolerancing. Now let us have a closer look at trial and error methodology of tolerancing. There are three basic steps to be followed here. Make up a tolerance value and see how does it work. Leverage the tolerance from similar old designs or drawings. Look up something in standard design guides, handbooks, etc. Next methodology is driven by customer requirements, such as customer provides specifications and drawings of the product, marketing feedback, FMEAs, failure mode effect analysis, voice of customer data. Next methodology is based on manufacturing process capability. Here we need to analyze the historical manufacturing process data and find the tolerances which make the manufacturing robust. Calculate worst case and statistical tolerances as appropriate. Work up to the assembly level for the overall tolerances. Fourth method is effective tolerancing, and we'll be discussing this one in details. An approach for this method is based on 4 points. The first one is assign assembly tolerances based on customer needs. After that, work down from assembly to components. Then, work up from known or expected component tolerances associated with appropriate quality level 3, 4, 5 or 6 sigma, depending on quality loss function. And finally, meet in the middle, working through the issues and negotiating with customer and manufacturing. Now we'll explore the benefits of effective tolerancing. There are 5 major benefits which can be listed down here. The first one is consistency. Then we have better designs. Third benefit is more accurate tolerances. And finally, lower cost. With this, We have finished our very first session on tolerancing. Thank you.
If you have any questions, you can find us on social media. Thanks for tuning in and have a great day.